Okay, fine then. Yeah. In previous class, we have started with exception handling. Right. We have seen what is the hierarchy of exceptions and the different types of exceptions. Right. And also we have seen try, catch, right, different keywords finally throws. Right. We will continue further on this in the exception handling. Right. Fine. The runtime exceptions, checked exceptions. Right. In the Java 8, right. In the Java 8, right. Currently, how we are closing the resource. In the finally block, we are closing the resources. Either it is a file streams or it is a database streams. Right. Why we are closing in the finally block? It will execute always whether exception is occurred or not. So that we will make sure that stream is closed. Right. In Java 8, they have introduced one more feature called try with resource statement. Try with resource state. Right. Try with resource. Right. Try with resource. Right here, we no need to close streams in the finally block. We no need to manually close it. We no need to write any code. Right here, how to write it in the try parenthesis inside parenthesis. Right, we have to create the file input stream object. Right, file input stream FIS equal to new file input stream. What is the path of the file? Right, we have to. This is called a try with resource. That means inside a try. Right, that means not inside. Try open close parenthesis. Give the file input stream object. Create the file input stream object inside parenthesis. It will close. Yeah. Resource once it is created, it will close automatically once the try block is executed. Once the try block is executed, right, it will close automatically. We no need to close it in the final block. Right, this is called try with the resource statement. It will close automatically. And we will see how to handle multiple exceptions. Right, how to handle multiple exceptions. One more is right, right, multiple exceptions. Okay, fine. All right, just it is a right here important block is so far we have written only one catch block. So far we have written one catch block. We can also have a multiple catch blocks. Right. What is the advantage of it? Right. If you want to do specific logic, whenever a array index out of bounds exception is occurred, I want to do specific logic. I want to execute specific logic. If null pointer, I want to execute specific logic. Right. For each exception, different types of exception, I want to execute different logic. Right. Then we will go for right multiple catch blocks, so that we can write based on the exception. Right. Based on that, we can write some different. Sometimes we'll get these scenarios also. But and also here we have to follow order child to parent. Right. First we have to write the child class exception, then parent. Right. If there is if we don't write parent class, what will happen? Right, nothing will happen. If we don't have parent class, array index out of bounds, suppose other than these two, if any exception is occurred, right, there is no catch block. Other than these two, if I want to handle, we'll go with the exception. Exception will catch all the exception under. This is the right parent class for all the checked and unchecked exceptions. Right, this is the parent class for all the checked and unchecked exceptions. Right. So whatever exception occurred, it will catch. Whatever exception it will catch. Suppose if I write this one first, right, what will happen? Any exception is occurred, it will catch it. It will not reach. It will not right. It will not reach here because it will accept. This is the parent exception. It will catch all. So we will get exception like unreachable catch block. Right. It is handled. It is already handled by catch block. Right. Exception catch block. So first we have to write the child class, then parent class. First we have to write the child class, array index, null pointer or arithmetic exception, file not found exception. Right, different types of exceptions. First child, then parent. Parent to child. We have to follow child to parent. Sorry, child to parent. Right, we have to follow child to parent. In Java 8, one more syntax. There is a one more syntax for multiple exceptions to handle. Okay. Right, we can have a try with catch block. We can write arithmetic exception. We can give pipeline. We can give single pipeline, and we can have null pointer exception. Right, like this we can handle multiple exceptions, null pointer or array index out of bounds. Right, in the single catch block, right, we can have like this also. All right, like this also. But what is the disadvantage here? Right, we for specific exception we cannot do. Right, if any exception, this is a R condition. This is like a or condition. If arithmetic exception, null pointer, array index, any exception occurred, this catch block will execute. But we cannot differentiate between, all right, what is the which exception is occurred. Right, but if Java 8 they have introduced, this is the one more feature. But if you want to have like this exception parent class, let's see, it will not allow. The explicit is already caught by exception. Suppose if you try to keep this one starting, that maybe we are keeping end, it is not allowing. Maybe suppose if we keep here, right, it will not also allow. Right, parent class exception, here it will not allow. Only child class exceptions. If you want a parent class, just write down another catch block. That's it. Right. Other than these exceptions, any exception is occurred, this catch block will be executed. This catch block will be executed. Right, like this also we can handle. And nested try catch blocks. We can have a nested try catch blocks. Right, nested try catch blocks. Right, we can have inside try block. Right, again we can have if required. Right, if required, again we can have a try block. Again try and catch. Again try and catch. Right, inside catch block also if you required, we can have again try and catch. Right, inside try block we can have. Inside catch block also we can. Right, wherever we want we can write it. Try and catch. Nested try and catch blocks. Right, nested try and catch blocks. Right, we can have nested try and catch blocks. Right, and then we will see. Right, exception navigation. Right, we will see exception navigation. Before that, we'll see one. We'll create one example to understand more. Right, we'll create a one class. Okay, bank. Right, bank will have double balance. Right, we can create a right constructor with some initial balance. Right, while opening the account, suppose initial balance. Right, if it is a less than zero, right, while opening the account, if it is a negative balance, throw exception, any exception we can throw here, illegal argument exception, throw new. By using throw keyword, what we can do, we can throw the exception. Throw new illegal argument exception. What is the message? Initial balance cannot be negative. Right, just assign that local balance to instance variable. Right, what else we can have? We can have a deposit. Right, we can deposit the amount. Suppose you, right, again, if the amount is less than or equal to zero, deposit amount must be positive. And also we can have a withdraw. Right, suppose while withdrawing, if amount is right less than zero, we can throw withdrawal amount must be positive. Or one thing, if we withdrawing amount is greater than balance, that means insufficient funds for withdrawal. Otherwise, we can just subtract it. Subtract it. Right. If you want to retrieve the balance, just get the balance. Right. We can create one test class. Right. To test it. Suppose bank test. We can create the main method and then bank. Right. Initial balance constructor. We are $100. Right. We can just bank dot deposit. Alright, suppose now I want to validate the balance, get balance. Right, just we will print it in system.out.println. Just execute it. Right, it should be $150. Right, 150. Now again withdraw. Right, again we can display after withdrawing 150 minus 30, 120. Right, if we try to withdraw, right, more than available balance. Right, more than available balance. It should throw exception. Right, insufficient funds for withdrawal. Insufficient funds. Right, suppose if we give negative amount. Right, suppose if we want to withdraw, that it will say withdrawal amount must be positive. Right, it will throw whatever exception we have kept there. Some meaningful exceptions we have kept. By using throw keyword, we can throw the exception with some meaningful exceptions. Right, fine. This is one thing. And then we'll see exception propagation. Right, exception navigation. Okay, exception navigation. Okay, suppose we'll create a public void. Suppose launch your. Okay, we want to create one user. Right, we want to create one user. Okay, launch URL. Just string URL. Just system.out.println URL. Right, Opening URL. That's it. Public void login. It just login. Then public void create a new account or something. Okay. Then public void log out from the application. Okay, these are the flow. This is the flow. Just right. Now I am calling right launch. If you want to call this method, how to call? Right in the static block. This is the static method, right? Main method. I cannot directly call. All right. How to call then? I have to create the object of it. All right. Object of it. Okay, fine. Here we can directly call launch URL login. All right. I will remove first. There is no try catch blocks. All right. Here what will happen? It will call the launch URL, then login, then create user login. Right. Instead of this, what I will do, this is a very simple. That's why I will create first launch URL. Inside launch URL, we will connect login. Right. Inside launch URL, I will call a login method. Inside login again, I will call create a new account. Okay, inside create new account, I will call login. I will call logout. Okay. Okay, fine. Okay, fine. What is it? Agree mode. Okay, fine. Object created, launch URL, and then here. Suppose now the flow is how it is going from the main method to launch URL. Launch URL is called login method. Login method calling create new, logout. This is the flow. Flow it is going like this. Suppose there is some error. Suppose there is an error in the login method. Right, while executing, right, just I will print divided by 0. Okay, log. Right, there is an exception in the login method. Now what will happen? Right, from here to main method, it is calling launch URL. Launch URL executed successfully, and then it is calling login method. In login method, we got a exception. First thing what it will do, JVM will verify, is there any try catch block? Is there any try catch block? Right, there is no try catch block. Right, there is no try catch block. Now what will happen? Who called login method? Launch URL. It will go here. Who called login method? Launch URL. Then again it will verify, is there any try catch? There is no try catch. Then who called launch URL? It will go to main method. Right, it will verify. Is there any try catch? There is no try catch block. Then who called main method? JVM. It will hand over to the JVM. Right, JVM. Then it will print the JVM will print right this message. JVM will print the message. Right, flow is like this. It will go flow. Right, suppose I have this is the main method, launch URL and login. I have a try and catch block. I have a try and catch block here. Okay, try and catch block. Now what will happen? See here just I am printing it. Right, there is a login. Right, catch block will execute. In the catch block, right, we are not doing anything, just printing. What will happen now? It will call the launch URL. It will go here, it is executed. Launch URL will call the login method. In the login method, we got inside a try block, we got exception. Immediately what will happen? Catch block will execute. Catch block will execute. Here what we are doing, here we are suppressing the exception. Right, here we are suppressing the exception. That means what? Flow will stop here. Right, flow will stop itself there. Let's see. Just we are printing caught an exception divided by 0, something redirected to some error page. Right, we should not do like this. Right, because it will stop exception flow. If you write like this, it will stop the exception flow. We will not understand what is the real exception. Right, we can log it. We can log proper messages. Then we have to rethrow it. We have to rethrow the exception. We have to rethrow the exception. That means what it will do, right? In the catch block, what we can do? We can do one thing. Either we can suppress the exception, continue the flow. Right? We can suppress the exception, continue the flow, or we can log the proper messages. Right? Then rethrow it. Right? Rethrow means what it will happen? Who called this login method? Launch URL. It will go here. Rethrow means again, right? It will go to launch URL. It will verify is there any try catch? No. Who called launch URL? Main method. There is no try catch. Then it will navigate to JVM. JVM will take care of it and it will print it. Right now the flow how it is, first it executed here. Right, it printed the opening. Then come to login. Inside login we got the error. Catch block is executed. Then we are rethrowing it. Suppose if you rethrow it, what will happen? See, we will get again this message. JVM will print this message. Right, exception flow is like this. It will go on like this. Right, suppose if you want more clear. Right, simple things. We have A, B, C. Okay, these are the suppose methods. Right, A is calling B method, B is calling C method. Right, A executed successful, A calling the B, B calling the C. Now C exception is occurred. What will happen? First thing, JVM will verify is there any try and catch block. Right, try and catch block. If there is no try catch, it will go to who called C, B. It will verify, it will go and verify is there any try catch? No. Then who called B, A. It will verify is there any try catch? No. Then JVM will take care of it. Suppose same scenario C, we have a try and catch. We have a try and catch. That we have a try catch blocks. That exception is occurred. Exception is occurred in the C block. First it will verify is there any try catch? Yes. Then catch block will execute. If you are not doing anything, what? Suppress. That means it will stop execution here itself. It will not navigate back again. It will not navigate back again. It will navigate flow forward only. A to B, B to C. See, you are suppressing the exception, then it will stop. Right? Don't suppress the exception. Right? Do the proper logging, do the proper messages, and then rethrow it. Rethrow it. Then if you rethrow it from C to B, it will navigate back. It will navigate back. It will verify is there any try catch? No. Then it will go to back to A. There is no try catch block. JVM will take care and print it. Right, JVM will take care and print it. Right, just it will go as a navigation back. If you rethrow it, it will go navigation back. If you suppress it, it will stop there. Right. Any questions? Right. Any questions? Okay. That's fine. If you understand, that's fine. Right. If you have any questions, please. Right. Then we will see exception printing. Right. How to print the exception. Right. We have different ways to print the exception. Okay. Fine. Uh, we'll create one more. Print exception details. Right. We can print. First thing is print to stack trace. Right. First one is print to stack trace. Suppose if I print stack trace. Right. In exception, every exception will contains three details. Right. One is the exception name, and second one is the what is the reason, that description of the exception. Third one is stack trace. Right. What is the stack trace? How the call happened. Right. From where to where call happened. By using this, we can understand where the exception is occurred. Right. If we click on it, it will go to that class. Suppose, okay, in Java 8th line, print exception details class, we got exception. See here, because we are dividing by 0, it got exception. Now what? Print stack trace will print all the details, exception name, description, and then stack trace. Stack trace. Now one more is get message. E dot get message. Right. It will print right only description. Only description. Right. Sometimes we require only, right, based on our requirement, we can only sometimes require a description only. Right. It will print only description. And one more is E dot to string. E dot to string. It will print exception name and we will keep it this one as a top. Okay. First we'll print stack trace, then E dot to string, then E dot get message. Right. First one will print both. We no need to keep under system.out.println. Right. Don't keep this print stack trace. No need to keep. It will print. Right. Keep system to string inside a system.out.println because it is returning the value. Here it is not returning void. Right. This method is not returning anything. We should not void things. Void methods we cannot keep under system.out.println. Right. If we print it, it will print only two details. Exception. What is the exception? What is the reason? And then third one, it will print only exception description. What is the description of it? Right. Sometimes we can, if you want a class name of it, exception class name, we can get it like this, arithmetic exception. What is the exception? E dot get class dot get name. We can get the get name. Right. There are multiple ways based on our requirement. We can choose which one we want. Right. Print stack trace, it will print it. But to string will print exception name and message. Get message will print only message. Get class dot get name, it will print only class name. Right. These are the some of the methods to print the message. And then we can see one more thing in the inheritance concept. Right. In interviews, mostly we will get a question like inheritance. Right. Parent class. Right. Then we'll create a child class. Okay. Child class extends parent. Okay. In the parent class, just will create one method. What display? Something display. Right. Same method I am overriding in the child also. Child also. Right. Now the question is, if a parent class, right, parent class is already there. Parent class throws some exception. Parent class is has a throws declaration. That means it has a parent class throws the exception. Is the child is mandatory to have this syntax, right? Is it mandatory to child also throw that same? Let's see. No, no. Whether it is a checked and unchecked exception, both. In interview, they will ask, what are the checked exceptions? Arithmetic exception. Let's see, there is no error. Still it's working. If it is a checked exception, suppose, file not found exception. Right, still there is not a mandate. If a parent is throwing a exception, child is not a mandatory to have exception. Right. If parent is throws, it has a throws class, throws keyword with some checked or unchecked exception. It's not mandatory to have child class. But coming to child is having throws some checked, unchecked exceptions. First we'll say unchecked exception. Right now, parent is not a mandatory. Child is throwing a unchecked exception or runtime exception. Parent no need to handle it. But child class is throwing checked exception, file not found exception. Now immediately we will get a compilation error. Is not compatible throws class in the parent class. When child class is having throws class with checked exception, must parent also must have the checked exception. Parent also must have. Right. When child class is throwing a checked exception, parent must have this one. Right. We have to remember only this scenario. Parent child is throwing checked exception, parent also should have. In remaining all cases, not required. Right. Otherwise, we will confuse. If you remember parent to child to, right? When child is throwing checked exception, parent also must declare it. In all the remaining cases, it will be optional. Right. It will be all the options. Right. See, it is also a checked exception. Exception is also a. Right. If we are throwing exception, parent also must have exception. If child class is throwing a checked exception, parent class must handle it. Otherwise, it will not help. Otherwise, it will not help. Right. Suppose right. Fine. Coming to now custom exception. Okay. Right. So for any doubts, we will go to final one. Custom exception, our own exception. So far we have seen predefined exceptions. We will see now custom exception. how to create the custom exception. Okay, fine. How to create it? We'll create it. We have created one bank class, right? Here we will do, instead of illegal argument, we will see, I want to throw, okay, bank exception. Okay, some meaningful exception, bank exception. I will throw, right, bank exception. Or specific exceptions also you can create. Suppose must be positive, but okay, negative balance exception. Or we can create like a class negative balance exception. Right, negative balance exception. Okay. Now, if we create like this, it's not a exception. We have to provide a feature of the exception. Right. This is just a normal class. We have to enable exception feature for it. How to enable? We can create either checked exception or unchecked exception. Right, checked or unchecked. If we want to create an unchecked exception, extends runtime exception. This is unchecked exception. This is unchecked exception. Let's see. First, we'll see this one. Later, we will just it is giving warning. Just right, add the serial version ID. This is the unique identifier to identify the class. Right, this is required by JVM. That's fine. It's not a mandatory. Okay, we can extend the exception runtime exception. That means it is a unchecked exception, either runtime exception or check. First step is this one, extends the exception. Then we can create the constructor. We can create the constructor and then message. What is the message we want to send? Right, what is the message? Then we have to call the super. Super means what? We have land. It will call the parent class constructor. Right, super means right, whatever we are sending, we are handing over to the parent, that runtime exception. It will take care of it. Right, then it will get the future of the exception. Otherwise, just a normal class only. Right, we have to hand over message to runtime exception. We can overload, right? Constructor overload. Either we can send only message or message with a throwable exception. What is the exception? We can, this is a throwable, right? That means we can pass anything here, any type of exception. Or we can, if you want to throw only throwable, we can have only throwable, we can have without anything, default thing. Right, if you want a default thing, we can also have a default constructor. And first thing we have to extend the runtime exception, create the constructor, inside a constructor, call the superclass constructor. That's it. Now on to our bank class. Right here, what we can do, we can call the bank negative balance exception. What we have created, what is the message, what is the name of the class negative balance exception. Negative balance, throw negative balance exception. Right. Right. Negative balance exception. Right. We can create any number of exceptions. Right. Any number of user defined exception. We can create any number. For each type of exception, we can create one class. Right. But when you are throwing a checked, see, runtime exception, unchecked exception, it's not mandatory to have throws class, throws keyword. Right. Whenever you are throwing a, right, this is also one more interview question. Whenever you are throwing a runtime exception or unchecked exception, it's not mandatory to have throws keyword. It's not mandatory. It's not a mandate. But if I create as a checked exception, how to create checked exception means extends exception. Extends exception. Now immediately what will happen? Whenever you are throwing a checked exception, whenever you are throwing a checked exception, we must have throws, add throws declaration also. That means we are throwing right. Someone is creating object of bank. We are intimating that checked exception means what? We are intimating that whoever creating object of bank, you may get a negative balance exception. Please handle it. Right. We have to tell them. Whenever we are throwing a throw keyword, throws keyword also we must have. See, all the methods are giving that error. Whenever you are throwing a checked exception, we must have throws. Right? Who calling? Bank test is calling. Again, bank test also must handle that. Right? Checked exception we can handle either by throws keyword or surround with the try catch. Right? If you use throws keyword, we are handovering to JVM. Right? Whenever we are see all the flow, right? See calling flow, we need to handle negative balance exception. Right? Whoever is calling, we have to handle it. Right? Flow must all the flows must be handled. That is the one of the design. Sometimes we don't require right. Then in that case we will go for runtime exception. Runtime exception means we no need to handle throws keyword. That is not mandatory. Right? We have to decide whether we require a runtime exception or checked exception. Checked exception means we have to handle in the throws keyword. Right? Whenever we are throwing a checked exception, throws keyword also must have in the method header. Right? Method header. Right? This is about one more thing. User defined exception. We can create either checked exception or unchecked exception. We must first step is we have to extend the exception and then create the constructors. If we want how many constructor, we can create those many. Right. Then inside a constructor, we have to call the superclass constructor. Inside a constructor, we have to call the superclass constructor. Right. Fine. Any questions? Anything missed? You want to know anything? I think I must covered all. Is there anything you have any questions or anything missed? And let me know. We can go through. Okay, fine. If you don't have any questions, right? With tomorrow class, we'll start with one more important topic: collections. Right? Collections. Very very important topic. Right? We'll continue on that. If you have any other questions, you can ask. Right? Not only this. Right? If related to core Java anything, you can.
Sir, I am little doubt about method overloading and overriding.
Okay. Right. What is method overloading? What do you have idea?
Overloading means you can change the signature of the method, not the body of the method. But overriding is in we can change the body of the method, not in the signature of the method.
Right. Suppose method overloading, what we have learned, we have a add method. Right. Suppose integer a, comma, and I want to add two integer numbers. Right. Here, method signature will be, method name will be same. That's it. Method name will be same. Suppose I can create one more method, add float a, comma float b. Right. Method name will be same, but arguments will be different. Method overloading means method name will be same, but arguments will be different. Right. Either number of arguments or type of arguments, order of arguments. This is the type of arguments. First add is integer. Second add method is float. We can increase the number of arguments also. Right. Into a, comma, into b, comma, into c. We can increase the number of parameters. or order of arguments. You can create int, float int methods. Right. Method overloading means method name will be same, but arguments will be different. Either number, three conditions, either number of arguments will be different, type of arguments will be different, or order of arguments should be different. Otherwise, what will happen if we create same method with int again duplicate method? It will say duplicate method. Right, where we have created polymorphism method overloading. Right. See, here we are creating method name will be same, but arguments will be different. Arguments will be different. If we take the one of the example, we have a what example? Right, math. In the math class, if we say these are all ABS, absolute, right? These first four methods are method name is same, but arguments will be different. Double, float, int, long. Right, these are all ABS extract. Right, seal, flow. Right, this floor DB extract. Right, method name will be same, but arguments will be different. That is called a method overloading. But method overriding means it will come into picture when you have a parent and a child. Parent and a child. Right, we are overriding the parent class method in the child class with the same signature, but body will be different. Right, but body will be different. That is called method overriding. Overriding the parent class method in the child class with a different body. That means functionality. We should not say body or something. Right, in interviews, always use the special terminology. Right, overriding the parent class feature or parent class method in the child class with a different functionality. With a different functionality. Right, that is called a method overriding. Right,
Sir,
in method over, yeah,
sir,
tell
in
me.
method overloading, we can achieve within one class, but overriding, we can achieve multiple class only.
Right, if we have a parent and child, then only you can achieve. Otherwise, you
Overriding,
can,
not
you can,
okay.
you cannot.
Okay, okay. Yes, thank you.
Okay, any other thing? Anyone have any other? Okay, fine then. We'll continue tomorrow. We'll connect it. Right. Just I'm posting my videos. Just like and comment it. I am saying only Kavita and Swati. Thank you very much, Kavita, Kirti. Right. Remaining people, just take 1 minute of time. Just comment, like and comment. Right. Whoever commenting, thanks for them. Right. Thank you.